Hi students, let's look at this question here, which is an interesting question taken from the year 2015 RVHS mid-year J2 question 8. Alright, so this question is on permutation and combination PNC. So you can do this proficiently. Okay, so I think the first part is pretty okay. The diagram below shows a pin board with 90 pins. So 90 pins means that we have 2, 4, 6, 8, 9. This is 9 pins horizontally, and after which we have 2, 4, 6, 8, 10 pins vertically. All right. Now so what we're gonna do is a rubber band goes around the pins to form a geometrical shape. So congruent shapes formed with different pins are considered distinct. So example, what I'm saying, what they're saying is if there's a 3 by 4 rectangle here, is different from a 3 by 4 rectangle here. Even though they are congruent, but they are considered the same. I mean, even though they are the same, they're congruent, but they are considered distinct. Okay, so rectangles are formed such that their sides are parallel to that of the board. Okay, so how many rectangles can it be formed? I think the first one is pretty okay. The first one is quite straightforward, because to form a rectangle like that parallel to the board, it has to be a rectangle like that or a rectangle like that, right? So it is like any rectangle will do. So what you should do is from this, out of these 9 pin, okay, you choose two sides, essentially out of the 9 columns, right? You choose 2. Then out of the 10 rows, you choose 2. Okay, 10 choose 2. This will be a rectangle, right? So the number of rectangles you can form is actually 9 choose 2 multiplied by 10 choose 2. Okay, so essentially you choose so this is a number of rectangles form is 9 choose 2 times 10 choose 2. The first part is pretty okay. So you just key in calculator, 9 choose 2 times multiplied by 10 choose 2. There will be 1620. Okay, I think the interesting one is the second one. So triangles are formed such that at least one of the sides are parallel to that of the board, one of the sides. So essentially we can't have a triangle like this. Okay, we can't have a triangle like this, all of it which are not parallel to the board. Okay, so if any form of triangle, I think what if say there's just form any form of triangles, there will be 90 choose 3. That will be easy, but this case it is 4 marks, so you have to pay a bit of attention. On top of that, what they told is actually the area of the triangle is given is actually 16 square units can be formed. Okay, so essentially we need a triangle which is like one side parallel to one of the side of the board. So this side here, it could be this obtuse angle here, or it could also be another form which is like that. So try and understand the question first. So here, okay, now each vertical and horizontal distance of the pin, I assume is just 1 unit, although the question didn't say it's 1 unit, so I think we could just say that it's just 1 unit. So anyway, they did say it's square. Okay, so 16 square units, so I'm just going to assume that all these are like one unit apart. Okay, so how do we break this question down? I think the first thing is to understand that any given, we need to understand how many types of triangle we can form. All right, and essentially what we understand is half, any kind of triangle given to us, it will be just half times base times height, right? So regardless of whether it's an obtuse triangle or not, this will just be like half times base times height. Then this has to be like 16 units square units, right? Then after which, this is where it becomes fun, because we know BH will just be 32. Okay, so how do we make sense of it? Now this is where you use prime factorization, because by using prime factorization, you can actually see how a composite number behaves. Prime factorization is like atoms to numbers, like prime factors. Prime numbers are like atoms, right? So essentially, if you are able to prime factorize it, you can sort of guess what the number is made of. Okay, so this is 2 to the power of 5. So essentially what we're looking is 2 times 2 times 2 times 2 times 2. Now this is interesting. Then this will tell us how we would orientate our triangle. Okay, so the first thing is we could essentially just group, like our base could be 2 and then our height could be 2 times 2 times 2. But the problem here is this will be 16 and this is 2 is okay, but the problem is 16, we don't have enough length to accommodate 16 because there's only 1 2 3 4 5 6 7 8 9 units length for the 10 pins. So you just count the gaps. There's 8 units here. Okay, 8 units here. So essentially we can't have this. We could also put a, actually just imagine there's also a 1 here, but because of the restriction of the board, we can't have a 1 times 32 units, right? So what we could is actually our base and our height. This could be our base, which is 4 units length, and our height can be 8 units length. Okay, this is case number 1. Height is 8. We could also separate it as in a way where so we could base equals to 4, case 1 sort of, then height would be 8. Okay, case 2, it will be base, I think the base now will be 8 and then height will be 4. Okay, so these are the 2 cases I will consider. Okay, so because this case here, we will just look at how we're gonna define it. So I actually just duplicated the board here for all the cases. So let's look at case 1. So case 1, base is 4. Units. Height is 8 units. Okay, you realize that there are 2 types of orientation. So case number 1A will be we are talking about 4 units this direction, the base here. So then you have 8 units, 1 2 3 4 5 6 oh, there's only one way. So you can have like this over here. So this is like 8 units. It's 8 units length. Then this is 4 units. Okay, but don't forget that you could also be a mirror image here. So essentially you can have a 4 and out of that you can have this one. Okay, so the 4 is also here. Okay, 4 units and 8 units here. Okay, great. If the base and the height. Then case number 2, don't forget, case 1B, is that the 4 units will be here. Now it can be this direction here. Then the 8 units is vertically up. So 1 2 3 4 5 6 7 8. So it's like that. Okay. And don't forget, of course, we could also draw the triangle in this direction here. So it's 1 2 3 4 5 6 7 8. 4 units and then 8 here. Okay, let me just draw it so that it's not so hard to understand. Label it. Alright, I think once we establish this view orientation, then it'll be alright. Okay, so I think let's look at that. I realized that I drew wrongly for the previous part. So this is 3 units. So 4 units will be like 4 units apart, right? So it'd be like something like that. Actually, there are 5 dots apart. So 1 2 3 4 5. Count the gaps. Okay. Now, essentially, when you look at this diagram here, what we need to do is essentially understanding that the number of angle formed on this side and this side is the same, like the number of angles, right, where the base is leaning to the left or the right. So we just need to calculate once and then we just need to multiply by 2. Am I right? So this case here, what we know is let's try and count how many 4 units of it we could form. So 1 2 3 4 5, like I said, there are 1. This will give us 4. The basis is 4 1. So we can move. This is 1. Then after which you can move down 2 3 4 5 6. Right. So there are 6 ways for us to actually choose to position our base, right, on in this form here. So 1 2 3 4 5 and 6. So there are 6 ways to position our base. 6 ways. Okay. After which the 8 units here, actually there's only one way because we only have 8 gaps to accommodate. So 1 2 3. So just calculate this 1 2 3 4 5 6 7 8. Okay, so that's it. So if there are 6 ways here and 8, there's only one way, one gap there. Then just remember that we 6 ways to choose the 4 base. Then there's only one way. Then this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can choose, you can even choose your, let's say we have these 4 here. Okay. So we have this 4 here, which is this one. We can either choose our end vertex to be here. So they are like 1, 2. If we choose this one, we can form another triangle here. Right. So look carefully. I hope you're able to see that. So we the vertex, when we choose this base of 4, we could actually choose like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? 10. Okay. So now this is 10. Now don't forget, we can flip. Just now we discussed that. We have already discussed that the base can be the side. So times 2, 2 ways. Okay, 2 sides. So you can actually times 2 to both sides there. So this is essentially the number of ways to position the base, which is 6 times. Then this is number of ways to position the height. This is the number of ways to choose the vertex here, and times 2 we can flip. All right, so we're going to use the same concept for the subsequent one, which is actually 4, and then after the height of 8. Right, so 1, 2, 3, 4. Yes. Similarly, I'm going to count. So 1, 2, 3, 4. This is one way to position the base. So 2, 3, 4, and 5 ways. Right. So there are 5 ways to position the base. So it's 5. Okay. Then after which we need to ask is 8, right? There are this is 4 times 8. So how many ways to position the height, which is 2, 4, 6, 1, 2, 3, 4, 5, 6, 7, 8. There are only 2 ways. Okay, 2 ways to position the height. Then we need to count the number of vertex there that we can choose, which is actually 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's 9, 10 times 2. So this logic follows the same as this over here. Okay, so for example, I could actually choose this 4 here. Maybe I just use another color. Let's say green. So I could choose a base of 1, 2, 3, 4 these units, and after which it means it belongs to this height. Then after which I'm gonna just multiply by like that, right? So I can just pick any of these 9 to be my end vertex there. So this is for this case there, for case B. So this is just write something in the exam so that the examiner would know what you're writing. So this is where the base is parallel to the vertical side of the board, and this is where the base is parallel to the horizontal side of the board. Okay, so times 2 is the same thing. I'm going to use the same logic, same alignment here. Let's look at the case 2. This case 2, we just need to be slightly careful. All right, I'll just explain. So essentially what we need to understand is the base now is 8 parallel to the horizontal. I did the vertical first, was it? Okay, I think I should just do the vertical one for the case 2A. Okay, what we get is 8 units. We can have 2, 4, 6, 1, 2, 3, 4, 5, 6, 7, 8. So there are these choices, among choices here. So there are 2 choices for the base. Then whereas for the height, we got we have more than what we had in the previous 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so there are 1, 2, 3, 4, 5. Okay, 5 ways. So it's 2 times 5. Now, the problem now is essentially how do you actually choose the last vertex, right? To avoid, okay, so let's say if I were to choose the base as this guy here, okay, this is, let's say, this 8 guy here, and essentially I could actually choose any of these 4. So it will be my vertex will be in this column here, right? This column. I can choose this as my last vertex, not an issue. But the problem is you shouldn't choose this as a vertex. Alright, this as a vertex, because this would render the horizontal. This will be like this. There will be a double counting. It will be consisted in one of these cases here, which is this part. Okay, you will this particular arrangement would actually be in case 1b. So you have to minus off 2 actually. You cannot take, so this, you can't choose this, and you can't choose this as well, because these both would be a double counting from the other case there. Okay, so this as well, you can't do that. So you can't choose these two. So out of the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you could only choose 8 vertices. Okay. Right, so if you run out all the columns, it's always the same. You can't choose the one which will make the height be horizontal, be parallel to the horizontal side. So then same thing, you multiply by 2 sides, because you can also have the base on this end as well. Okay, so you can that's the idea. So same thing for case 2b. Base is parallel to the horizontal side, so I could just choose this one. 1, 2, 3, 4, 5, 6, 7, 8. So there's only one choice actually. But the height, we have 1, 2, 3, 4, or 1, so 2, 3, 4, 5, and 6. 6 choices, right? Same thing for the vertices. When you choose, say, 8 like that, you cannot choose this. So you'll be height of 4, right? 1, 2, 3, 4 here. We can't choose this vertex here because it will double count as the previous case, and this over here as well. You can't double count this side. So the choices you have is 1, 2, 3, 4. The middle dot 1, 2, 3, 4, 5, 6, 7, 8. Right. So 8. Then after which, what we need to do is multiply by 2. Sorry, 7, not 8. Subtract 2. So you add everything up, you'll be 544. So answer, you add all the cases up, which is 120, 180, 160. So I'll just write it down. Case 1, case 2, case 3, and case 4. All together we'll get 544 ways. Okay, so that's all for this question here. Proficiently, just be careful of the nuance that and all the different steps. Okay, so I'll see you in the next question.